Hi everyone, welcome to the Age. We are under trigonometry and we are still busy with finding the general solutions, solving for angles. So here we are given a slightly different situation because as you can see on both the left hand side and the right hand side, we have the same trig ratio, sine and sine. And usually with general solution, we would want it that there's only one trig ratio on the either on the left hand side or on the right hand side, and then on the other side is just the number, maybe such as sine x is equal to 0.5. You would want a single trig ratio and then the number on the other side. So here now we have two trig ratios and both of them have variables that we have to solve. So how are we going to work this out? I mean, it's pretty much the same thing. So yeah, you have to decide which one do you want to make the subject of formula, this one or this one. You can either make two of them the subject of formula. Either way, you're going to get the same general solution, just slightly different. Now, what do I mean? Okay, let us start by making firstly the sine 3p as the subject of formula. So we know that with general solutions, you would want to go to your calculator and type shift sine and then of whatever you're going to get on the right hand side, right? In this case, we really cannot type 2p into the calculator. So you're just going to say, it would be like saying 3p is equal to shift sine of sine 2p. And when that happens, it's like this sign and this sign cancels, and then you're just going to be left with 2p, right? But in this case, we know that firstly with general solution, we want to get our reference angle, ref angle. So yes, in this case also, the reference angle will be shift sine of sine 2p. The signs cancel, it's just going to be 2p. That's how you can look at it as your reference angle. And then we know that the second step is we look at the cost diagram. Cost. So usually we would ask ourselves, so for instance, going back to that example of maybe if we had sine x is equal to 0.5, we would ask ourselves, in which quadrant would 0.5 be positive? Because 0.5 here is a positive number. You can imagine that there's a positive there. It would be at the all quadrant and the sine quadrant, right? Cool. But now, yeah, we have a different situation. We have to ask ourselves, in which quadrant is sine 3p going to be sine 2p? So it's like, in which quadrant is sine going to be sine? You know? And that's exactly how you have to look at it when you get this sort of situation. In which quadrant is sine going to be sine? In which quadrant is sine going to be itself? We know that it is the sine quadrant, of course, right? But then the all quadrant as well. Because in the all quadrant, all of them are belong there at the all quadrant. That's why it's called the all quadrant. Cos, tan, and sine all belong to this quadrant. They share this quadrant. And then for the others, it's like they each belongs to their own. Sine belongs to sine, tan belongs to tan, cos belongs to cos. So in this situation, we are answering that which quadrant is sine 3p at sine 2p? We said, okay, sine 2p belongs to its sine quadrant and to its all quadrant because all of them share the same thing. So we are going to use these two forms, right? And we know that this angle is a reference angle. So we're going to say 3p, let me just erase this for confusion. 3p is equal to reference angle plus k dot 360 degrees, right? And then another solution would be 3p is equal to 180 degrees minus 2p minus this, yes, plus k dot 360 degrees. So we would have two solutions. And so what we would have to do now here is to solve for p. Let's start with number one. It would be 3p You take the 2 over to the other side, it's going to be 3p is equal to 2p. 3p minus 2p is equal to plus k dot 360 degrees. I guess you don't even need to say plus because it's alone now. 3p minus 2p is equal to p. So p would be k dot 360 degrees. That's your first solution. Second solution is this one. Let's work at number 2. So we do the same thing. 3p, take this minus over to the other side. Now it's going to be plus 2p is equal to 180 degrees plus k dot 360 degrees. 3 plus 2 is 5p is equal to 180 degrees plus k dot 360 degrees. You divide the 5 on both sides, you're going to end up with 180 divided by 5 is 36 degrees plus 360 divided by 5 is 72 degrees. So now you have two solutions for P. So like I said, this one is for when we made sine 3p the subject of formula. So now let's try to make sine 2p the subject of formula and see what is going to be different. I shrink what we just did there at the top left. It's very small. But now let's say that, okay, we had sine 2p is equal to sine 3p, right? And now it would be like ref angle is equal to sine 3p, the signs cancel. So the reference angle would be 3p. And then referring back to our cos diagram, we know that sine belongs to all quadrant because all trig ratios belong there, and sine belongs to its quadrant indeed. Now we are, yes, this sine belongs to this sine indeed. So it's going to be 180 degrees minus angle and angle over there. So let us go ahead and say 2p is equal to, firstly, 3p is equal, 3p plus k dot 360. And now if we transfer things, we're going to get p is equal to negative k dot 360 degrees. That would be our first solution. Second solution would be 2p is equal to 180 degrees minus 3p plus k dot 360 degrees. Transfer it over to the other side, we're going to get 5p still, 180 degrees plus k dot 360 degrees, pretty much the same as the one we got there, which is 36 degrees plus k dot 72 degrees. So yeah, as you can see, okay, we kind of got the same thing, but yeah, we got, let me rewrite this a little bit bigger. For when we made 3p the subject of formula, we got k dot 360. When we make 2p the subject of formula, we got minus k dot 360, whereas the other two are correct, so which is fine. But what you want to notice is these are also kind of the same in a sense. Don't let this negative distract. Oh, I forgot to say k is elementary to z. Yes. So this k can also be negative. When you sub negative k here, you're going to get a positive. So now it's like this one is telling you that you're going clockwise. The positive is telling you that you're going anti-clockwise, right? But you would still get to the same point. Whether you're going clockwise or anti-clockwise, you would still get to the same point. That's why you kind of have to look at them as if, okay, whether this is negative k dot 360 or positive k dot 360, it really wouldn't matter like that, right? Because, like I said, going clockwise in 360 degrees or anti-clockwise in 360 degrees, it's going to get you to the same point, right? And so generally it's like it's also kind of the same. It's the same general solution in a sense, just that the other one is going in a different direction, the other one is going in a different direction, if I kind of make sense. So yes, you just have to apply this thought process in other trig ratios as well for cos and tan. And I hope I at least made sense. If there's something that I said that you still didn't catch, you can always leave your questions in the comment section. And if you found value in this video, please hit the like and subscribe button. And if you would like to see more examples on this, also leave in the comment section. I am happy to elaborate further. And yes, thank you very much, guys. Enjoy your day.